to now continue with a session specific about Python. And we're going to talk about the pip and venv Python packages and how they can help you to install and manage Python packages. So pip, the most plausible abbreviation I could find was that it stands for pip installs packages, but there are a few variants of that, and so it's quite a popular package manager for Python, I think. And venv, the idea is there that it allows you to create virtual environments that are quite lightweight, that allow you to install different sets of packages in isolation from each other. But before we're going to dive into the actual tools, we're going to motivate a bit and then provide some context and comparison with some other methods for installation. Something that has been said before is that if you install some software, in this case a Python package, there are typically a number of dependencies, so a number of additional packages that need to be installed. And one thing that often happens in Python is that APIs are not very stable, which means that you need often a very specific version of a certain package as a dependency. If you then take into account that there are transitive dependencies, so dependency of dependencies, you can imagine that you get quite a complicated dependency graph quickly. And so if you look at the example on the screen, you can see that you want to install my app at the top, but then there are transitive dependencies, which mean that it actually needs version 2.3.1 of requests, but also version 2.5.2. So that's clearly a dependency conflict that you cannot resolve. And while this example is pretty straightforward, you usually want a package manager to figure that out for you, and then hopefully not run into conflicts, but have the package manager tell you exactly which versions of all dependencies would work. So similar to a slide you've seen before, these are dependencies between popular Python packages. It's not specific to DB-Lite. Don't worry about the details. It's just to indicate that there are quite a lot of dependencies in software that you will typically use. So then the second tool that we're going to use in combination with pip is venv. One thing that's very common is that you will need sets of packages that are not compatible. For instance, you need one set of packages to run a simulation and then another set to post-process your results. And so an easy and convenient way to do this is by using virtual environments. Set at the start that these are lightweight environments, and the main reason to say that is that in contrast to the Conda Mama Pixie approach we saw earlier, the Python interpreter actually lives outside of the environment. So next to keeping cleanly separated environments on one machine, it also can help to reproduce a certain environment on different machines. And one thing we'll come back to in the demonstration is that you can combine these with packages outside of the environment. So that's also a difference with Conda Mama Pixie. This slide aims to situate the current talk in relation to previous methods that were discussed to install Python packages. So everything is relative to each other. When I put a plus or a plus plus, the plus plus means it's somewhat better. Of course, there is always a subjective component. So when you look at ease to use, I would say that pip plus venv is a bit easier than Conda Mama Pixie. The main motivation is that with Conda Mama Pixie, you need an external tool, while these pip and venv, they are built into Python. Then there's also the centrally installed modules approach, which was discussed in the very first talk. That's also easy to use. You do module load and you get the Python package. I mean, if it's a module for a Python package, of course. But the caveat is, of course, that you need the support team to install it for you. And if you look at the landscape of Python packages that's available, then I think it's easy to see that we cannot provide modules for every single Python package. If you look at how much control you have as a user, Well, if you rely on centrally installed modules, it's very small. The only thing you can do is ask us politely to install the module for you. With pip plus venv, you can have more control, but you're limited to the interpreter that you can use, while Conda or Mama or Pixie, there you have nearly full control over what you install. Same thing is reflected in the isolation, so Conda is more isolated than venv. The modules are somewhere in between, I would say, depends a bit on how you look at it. One of the ideas behind this whole module system is that you isolate what's in the modules from what's in your operating system. But of course, there are some libraries that are linked, so yeah, it depends a bit on how you look at it. And then the last two rows look at storage requirements. So this was already touched upon earlier. In a Conda environment, typically this is quite high. You will both occupy a lot of disk space and need a lot of files. Specifically for the TB-Lite example, if you install TB-Lite-Python in a Conda environment, you get about 11,000 files, while the same thing in pip plus venv is about 3,000. Also for the disk space, it's about 3 to 4 times as high. When you compare the centrally installed modules with the pip plus venv approach, it's probably similar, but you can argue that it's a bit less relevant because those don't count for your own quota. So maybe there's one thing that I want to talk about a bit longer here, and it's maybe a dangerous thing to say, but let me complete what I'm about to say. So storing a lot of small files on a file system in itself is not necessarily bad, right? As long as they are just sitting there, they don't cause any trouble. There is a theoretical limit on how many files you can store on a file system, but normally you will run out of disk space way before you reach that limit. What is, however, quite important in an HPC environment is how often you access those files. So if you load an environment a lot of times, for instance, you're doing high throughput calculations, and every time in every element of your high throughput computation, you need an environment that goes through all files, then you're really putting a lot of stress on the file system. What makes things worse is that these file systems are typically distributed, or at least shared to make them available on all nodes. But then also you have to share them with other users. So one thing we sometimes see is that one user is doing really a lot of metadata operations, for instance, because they're loading an environment over and over again. And then all the other users suffer from that. So if you ever had the experience of going to a login node and noticing that everything is lagging a bit, there's a chance that some user is just doing, is messing things up for everybody. So this is why the number of files that are in your environment does matter, but actually only when you access them. Okay, hopefully that clears things up a bit. And then maybe also important to mention is, so with Conda, you get a very high number of files, but then of course, if you can containerize it, then it maybe becomes the best approach, because from the point of view of the file system, a container image is just a single file that has to be loaded in memory. And from there, all the files inside there are like virtually accessed through the memory, so they don't put any additional stress on the file system. Okay, so that was a bit of an aside to clarify some things, hopefully. So now we can get to how you would use these tools. And I'm going to jump straight into the demonstration. Okay, so I am in my data directory. Normally, that's a good place to store your virtual environments, unless there are some site-specific regulations. But the first thing we need to do is create an environment. So therefore, for that, we're going to use the venv module. So if you want to call a module from Python, use python-m and then the name of the module. And after that, you're going to specify the name of your environment. So I'm going to use my first venv, and then it takes a few seconds to set this up. Okay, and what has happened now is that it created a directory, my first venv, and that will contain everything related to this virtual environment. So this is something you only need to do once for every virtual environment. But then if you want to make use of the environment, then you need to activate it. So you do that with the source command, and then you provide this specific script as an argument. So it's always in the /bin directory that the activate script is located. And now our virtual environment is activated. And if you set up your terminal a bit, then you can show here in the prefix which virtual environment is activated. So one thing that we can do is have a look at which Python interpreter is now used. And at first sight, you might say, well, this is located inside my new virtual environment. But if you look a bit closer, you will find that it's actually a symlink. So this is the bin directory inside our virtual environment directory, and it points to /user/bin, which is the system Python. So that was also the version of the system Python that's installed on this specific machine. Okay. Yeah, so checking the version of the Python interpreter that you're using could be important because you typically want one that's recent enough. So now we're going to start using pip. So that's a module that is now available, and so you call it with python-m pip, and then we can install some things. What's usually a good idea is to install pip again, but update the version. So unless you have a specific reason to use an older pip, this is something that's probably a good thing to do. And after that, we're going to install the running example, which was tblite. And we're going to request a specific version. And the syntax therefore looks like this. So 2 equal signs and then the version number. So let's see what happens. So as you can see, it's collecting a number of packages because pip under the hood worked out what are the dependencies. And then apparently, because I ran this in advance, there are some files that needed to be downloaded already present in my cache. But after that, it installs a number of packages, and you can see those here. So there are 4 to be specific. Now, you might think that's quite a low number of packages, especially if you think back to the morning session where Kenneth showed this dependency graph of tblite. The important thing to note here is that in this PyPy package, only the Python bindings are included, and then a pre-built library that contains the interface to the actual tblite. So for example, the executable tblite is not included, and there's also no compilation going on of anything. There are ways to override that. If you want to compile that library yourself via pip, you will have a lot more dependencies to fulfill. Okay, we can quickly check the installation. So just opening the Python interpreter and then importing it, and then you can print, for instance, the file that's involved. So that shows you where things were imported from, and indeed you can see that this points to the directory inside my first venv. If you want to switch to another venv, you first need to deactivate it. And since this is a very simple tool, you just type deactivate, and that does the trick. Okay, this I mostly set already. So by default, pip will try to pull in a binary version of any libraries that are needed, but you can use --no binary to compile it yourself. The same remark that Maxime made earlier applies here. So the binary that you pull in, it might or might not be optimized for your microarchitecture. It depends on the person or the people that created the Python package in the index. then a small demonstration on how you can reproduce a virtual environment. So first I'm going to reactivate my current one. Pip has this nice tool that will just list all the packages that are installed. That's called freeze. Not just the packages, but also the specific version number. And if we then save that as a file, which is typically called requirements.txt, but that's not really necessary, then it allows us to reproduce this exact environment on another machine. So first I'm going to deactivate my current venv. Then I'm going to create a new one. This is wrong, of course. This has to be venv. So now I'm going to activate the new environment. And if I don't want to install everything that's in the requirements file, I can do it as follows. So again, we're using the pip module from Python. And instead of now specifying the packages to be installed on the command line, we can just use -r and provide the file that contains all the packages we want, and you will see it recreates the first virtual environment. One remark, because the Python interpreter lives outside of this virtual environment, this will in principle only work if you recreate it on a machine that has the same version of the Python interpreter. Then there's one more slide with some slightly more advanced things. So there is a repository online called PyPy that hosts basically a lot of packages that are available, and people look there by default. But if it's ever necessary, you can specify other repositories as well using this. And then there are maybe two things that can be shown. Well, if you want to upgrade a package that's already installed, you can use --upgrade. I actually already showed that for pip. And then if you want to remove something, you can do it with uninstall. So maybe a short word of warning, it only removes the package I actually requested to be uninstalled, not its dependencies. Okay, so that's basically all there is to pip plus venv. Now we're gonna go one step further and use a tool that builds upon it, which is called venv. So because the Python interpreter lives outside of the environment, you can also combine this with centrally installed modules, typically Python packages, of course. And you would simply load the modules before you create and activate the environment. And then pip will take the packages from those modules into account before resolving the dependencies. So this has some advantages. One is that the storage requirements for your environment will decrease. And the other one is that you can normally assume that those packages coming from modules are suited for the specific hardware and operating system, which might not be guaranteed with a pip package. There is a small downside, it is that you need to remember which modules you loaded. And that's sort of what venv tries to rectify. And then at the same time, also making your environments architecture specific. It's not always necessary to create separate virtual environments for different architectures, but if you have some libraries in there that are heavily dependent or that need to be optimized for the hardware, then it's maybe a good practice to do so. So a small demonstration of venv. First, you will need to make venv available, and it's on all VSC clusters available as a module. And then we can have a look at how it works with help. So the idea is here that you provide at least one, but often two files. One is a requirements file that specifies the packages you need. We already created that just a minute ago, but now you can also specify a modules file which contains the modules that you want to use together with your virtual environment. So if we go up a bit again, we see that one of the dependencies was NumPy. So I happen to know that this is included in a SciPy module. So I'm going to look for a suitable SciPy module, and I'm going to use this one. And I'm going to put that in a file that's called modules.txt. And if we now start up via venv, specifying the requirements file and then the modules file. Oh yeah, I forgot the activate argument. I made a typo. Yeah, this should do it. So at first it will load the modules that I specified in my text file. Then it detects that my virtual environment does not yet exist, so it creates it. And one thing to notice here is that the environment automatically is named depending on the operating system and the architecture we're on. Because now this module has been loaded, the default Python has become the Python from that module, or that's loaded as a dependency of that module, which is Python 3.12. And then it will activate the virtual environment and again install all the packages from the requirements file. And as you can see here, it found an existing installation of NumPy. Did I do everything correctly? Yeah, I think something's not entirely correct. Huh? I think it's pulled in a newer NumPy version anyway. I have to look at that. Well, the warning is there. You need to make sure that the packages from the modules are compatible with the ones that you actually need. Yes. But I tried this earlier and I thought it worked correctly. But I'll have a look after the presentation. Okay, so then there's one more thing to do, which is to deactivate the environment again. And that's basically it. So then another small section about some alternatives. So there are quite a lot of different Python package managers available. I would say that it's good to have a brief look around what's out there, but then also just become an expert in one and stick to that. Often there are objective, but also some subjective reasons for people to prefer one over the other. For instance, you can say if resolving the dependency is faster, then that's obviously better. But apart from that, it's to a large extent personal preference, I think. What's also important is which packages are available to be installed with a package manager, because if it's very nice to use but doesn't support half of the packages you need, it's basically useless to you. So here's a brief list. One recent one that's got quite a lot of attention and indeed seems to be quite useful is UV. One of the things it does is it enables to resolve environments quite a lot faster than pip, and it should be a drop-in replacement for many of the commands. Alternative, there's also Poetry. I think it's a bit more aimed at people developing Python packages, but you can also just use it to install things. A small thing to mention is that we have venv, which is part of the Python standard library, but then there's also virtual env, which is like venv was originally split off from virtual env. So now virtual env provides a bit more richer features, and it should also be faster. Now, in principle, pip can be combined with Conda or Pixie, but then you're mixing two approaches and it's not always recommended, so it might give some unexpected results from time to time. So with that, my first recommendation would be to try out pip plus venv, but then if you're interested in any of these alternatives, you certainly can check them out. That's it. Any questions?
I should recommend UV because it also supports to install, for example, a specific Python version without having Python installed. Also, if you want to do it in a container, you only have to download that binary. You can install Python and all your dependencies without needing, for example, Conda or stuff like this.
Yeah, I agree with that.
There's a question in the chat as well. Is it possible in the environment to load any type of modules or only Python packages?
In principle, you can load any module if you need it.
Yeah, that's for the VSE venv tool, right? And I think the question is maybe some confusion about Python modules versus environment modules. I mean, there's a lot of overlapping terminology there. I'm not sure if that is what the question is about. But I think the answer is to the question as I understand it, Python virtual environments are specific to Python packages, right? You cannot install stuff from other ecosystems in a Python virtual environment.
That's correct. So, but if you have a module that has nothing to do with Python, it will peacefully coexist with an environment.
Yeah. Yeah.
Of course, then you can ask the question, what's the point of having both available at the same time?
Another question, is it possible to activate the environment when using an interactive session, for example, a Jupyter Notebook or RStudio?
Yes, RStudio would be weird, I guess, because it's really specific to Python, all of what was discussed here.
Yeah, I guess that question is on open on demand. Yeah, there's usually a custom code block.
For Jupyter Notebooks, what you can do is once you create your virtual environment, you can generate a kernel for Jupyter. And then in your Jupyter environment, just select the kernel that belongs to your virtual environment. And then everything that's available in the virtual environment will be automatically available in your notebook.
I'm pretty sure that's covered in the VSC docs.
Yeah, I think it's in the documentation, yeah.
Okay, any other questions? Yes.
So the VSC venv normally imports the globally packages from the modules in.
Yeah, when you load a module, your Python path will get adapted, and that's just taken over like inside your virtual environment. Right?
Yeah, because I think normally if you just do venv, you don't load the system installed NumPy, right? So
you do?
Ah, okay.
It will be accessible. I do think so.
Yeah, okay, great. Thank you.
That's sort of the point as well for VSC venvs, to encourage you to use the central software stack and the Python stuff installed in there, and only install the things that are missing through pip to make that combination a bit easier. That's the whole point of the VSC venv tool.
Also less work for us, because instead of having to ask us to install like a little small package, you can just do it.
Yep.
To include a job script, is it also possible with a virtual environment, or then you need a module?
No, if you write a job script and you activate a virtual environment in there, it will work. Yeah.
Okay, thank you.
Yes, okay. think we can move on.